Hey everyone, I'm Kiril Seksenov. I'm an engineer on the Microsoft Edge platform team. I work on web apps. So today I'll talk a little bit about web apps. I'll cover hosted web apps in depth. It's a new scenario for Windows 10. I'll move into packaged web apps and how you can take your HTML, JavaScript, and CSS, put it locally, and it'll run. This is great for static pages. I'll talk about the web view, and I'll cover Cordova, not too much. So starting off with Windows 10 apps and focusing on web apps for Windows 10. It's been truly a journey to get to one Windows and where we have a universal app platform where all apps, all universal Windows apps for Windows 10 run across all devices running Windows 10. And these apps run across desktop, across phone, Xbox, IoT, and Surface Hub, and HoloLens. So Windows 10 web apps are universal Windows apps. They run across all these platforms. They're just like any other native app. And what we did for web apps in Windows 10 is we took the Edge HTML engine, that's the same engine that's powering the Microsoft Edge browser, and the JavaScript Chakra engine behind Microsoft Edge, and we put them behind our app host. And what that lets us do is run HTML, CSS, and JavaScript just like it's running in the browser. So it's great for packaged content that's offline first, and it's great for hosted content that's remote. It's hosted on your servers, and you can just point to it in an application, and it'll be loaded. And you can also obviously mix the two, right? You can make a hybrid app that's packaged content and hosted content. So for hosted web apps allow you to use your existing web dev workflow, keep using your editor of choice, push your code to your servers, and then in a manifest, point to your website URL as a start page, and load it in our app host. When you load it in our app host, you get to integrate with the platform, and I'll show you how you get to do that. And you get Windows 10 capabilities. You also get to run across all Windows 10 devices like HoloLens, Xbox, and everything in between. So for creating a hosted web app, I just wanted to show how easy it is, and it's great to start off with a demo. What I'll do is I have this prepackaged folder. Let's open it up. And in here, I have an XML AppX manifest. This is the manifest that's used for web apps on Windows. I wanted to show how easy it is to wrap a responsive website that runs great in Microsoft Edge. I was going to take nick.com. So all I'm going to do is with nick.com, copy the website URL, place it as the start page in my manifest, and then there's one more thing that I have to do to make this run on Windows, and it's define the scope or the boundaries of the application. This defines the URLs that are part of your app. These will launch in the app host. They'll be part of your application. And URLs not defined in here, in the application content URI rules, will launch in the default browsers if they're included in your pages. So I'll add nick.com in here as well. Save that manifest. And then I'll open up a PowerShell command window. And I have to run one command. I'm already in that folder that I showed you. So I'm in this folder. All it contains is the manifest, some default error pages if I'm offline, which I shouldn't be, and my assets like logos and images for the taskbar and the start menu. I'll run that command, and what that does is it registers it as an app on Windows. When I go into Cortana, I can search for my nick.com demo, hit enter, and that should launch the application. It'll pull up nick.com in an app. I get an ad and close it. But it's that same site that I showed you. It's interactive, and it works. It just works. So it's easy to bring your website to the Windows 10 app platform. Go back to the slides. Now, what I showed you there, nick.com wasn't developed using the tools that I even used. They chose to use their own editor, whatever it was. They pushed to their own repos. They deployed on the services of their choice, and they were able to, or they could be able to reach Windows users if they publish a universal Windows app on the platform. Now, the next thing I want to talk about is how you actually integrate with the platform from your website. What this allows you to do is call Windows APIs, universal Windows APIs, from JavaScript hosted on your server. And how you do that is through the application content URI rules, basically the boundary that defines the URLs that are in your app. And you have to declare a Windows runtime access tag within there. There's 3 levels of access. There's all for access to the entire Windows namespace, the APIs that are in Universal Windows apps. There's allow for web only, and this is an example of where you want to add C++ or C#, any native code in your package, and then call it from your remote JavaScript code. And then none, which is just the default if you don't even specify a tag. So to really show that, I'll give you another demo. And this wouldn't be a Microsoft demo without Visual Studio, so I'll have to open it up. But this is just the same manifest that I showed. I showed how it was possible to create an app just through the PowerShell or command prompt. This is through Visual Studio. It works the same way, except you get a heavy code editor around it. If I hit run on local machine, that'll open up this demo app that we've built. Again, it's just a website. It's running in the browser. You can see it. It's a responsive website. The good thing here is, too, I've got this hosted web app. I can just hit F12, and what that does is launches the F12 tools, so you can debug your application. I can use the picker even to, let's say, select that text and live edit. So if I do that, my application changes. You can use F12 to debug your application, add JavaScript, use the console, everything that you're familiar with. And then to show this same application running on phone, I have a phone right here. Turn it on, and I'll get the Project My Screen app. Hit yes on the phone. This is just my device projecting. Same app deployed on the device. I can hit Contoso Travel, the tile, go into the app, and then book my travel. So I'll hit I'm going to San Francisco, book my dates. This isn't really interesting, but I'll keep going. And this is where the platform integration actually happens. So when I hit choose a friend, what I'm doing is feature detection for the Windows namespace. And if it's present, I can call the Windows APIs. This is the API for contacts. Choose a contact. That'll get passed back to my JavaScript, and I can put it in my website. This is just hosted code. I'll hit confirm. I can add it to my calendar. That calls another Windows API, a calendar API. Do that. And then finally, my trip's booked. I can send a toast notification on the platform. It'll pop open on the phone and remind me of my trip. So that's that same app running as a website and then running in the app host on Windows, both on phone and on desktop. And when it's running in the app host with the Windows runtime tag specified, you're able to call the Windows APIs. So next, another integration that we thought would be interesting for developers would be Cortana. Cortana is coming to the desktop. It's already been available on phone, and it'll be throughout Windows 10. So we've tried to make it really easy for web developers to integrate with Cortana, or at least natural. We'll keep iterating on this. We'll hear feedback and then try to make it better. But what we have today is the ability for you to add a voice command definition file on your server. This is an XML VCD file that Cortana uses for developers to specify voice commands for their application. So these commands are registered with the platform, and then when a user speaks to Cortana, it'll invoke the application and pass back the speech reco. Then you add a meta tag in your HTML, your start page. This is how the meta tag actually looks like. It's a MS application Cortana VCD. And then you specify a link to your VCD file on your server. This is all hosted on your server. And then this is just a sample of what the JavaScript on your server, again, would look like to handle the Cortana activation in order for your app to take back the speech reco from Cortana and do something cool. I've got a demo of that as well. and then so I'll show you that. This is just actually a team that I was working with. They were developing this video player app, and I said, just a web app, and I said, well, wouldn't it be cool if we could add Cortana integration to this? And they said, sure. I had no idea what they were doing. I just went in and added the Cortana activation code and the meta tag and the VCD file. So the VCD file, just so you know, it's a pretty simple XML file. For here, I've just specified one command. It's the play command. And what that lets me do is speak to Cortana, name of my app, Contoso video in this case, and then play some video. So I've done that. I've defined my command, and then I'm giving feedback to the user saying with stream demo. In the index.html, on my HTML page, I have the meta tag that when the app is run in the app, when the website is running the app host on the platform, we'll look for that meta tag, we'll find it, we'll suck down the VCD file, register it with the platform, and then your app will be able to receive voice commands. And then here, I have the Cortana activation code. I'm feature detecting for the Windows namespace. I go in, I look and see that it's a voice command activation. From there, I'm able to extract the results of the speech reco, and then also get the actual command that was uttered to Cortana, and then play a couple videos. So this has been a little wonky, but let's see if it actually works. Contoso video. Play Tears of Steel. So Cortana's pretty good. It actually caught that. And there goes my application. This is just a hosted web app like I showed. The voice command recognition was passed back, and it's playing the video in the player. Same code that I showed. So that's an example of how you could add Cortana integration pretty easily, pretty fast if you wanted to do it. And then I know everything I've been showing here has been with the XML manifest. It's not the standard JSON manifest that many of us are used to. We're doing work on that. We have an open source project out there in the community called Manifold.js. And what this does is uses that same JSON manifest to start and allows you to create an app cross-platform. You're able to publish this app not only on Windows, but also on iOS, on Android, and Firefox OS as well. But in the future, we'll keep contributing to this project. You're welcome to as well. And we'll keep moving forward, integrate this with the platform, so we're able to start with a JSON manifest for a web app and keep going from there. So that was a little bit about hosted web apps or a new scenario for Windows 10, a couple demos. Next, I'll talk about packaged JavaScript applications. These have existed in the past on Windows. They're just native HTML, JavaScript, and CSS apps on Windows. It allows you to copy and paste your server code locally, and that really works only if you have a static page. You're going to need to be connected for other things. WebView is obviously still able to navigate to remote content. These apps, just like hosted web apps, use the same Edge rendering engine behind Microsoft Edge. They use the same web platform. It's always up to date. And the biggest change that we've actually made here since Windows 8 is adding content security policy to be the security model for all apps. And that's only for the local context. You could also switch to the web context, even for packaged apps, and that allows you to have no default policy or specify a policy of your own. Next, I'll touch base on the WebView control. And the WebView control is an important control for all apps because it lets them bring remote content into packaged content pretty easily. WebView control, again, uses the same platform, same Edge rendering engine and JavaScript engine that's built for the modern web. We tried to add a rich API set around WebView, and we keep getting feedback and adding more and more APIs that give developers more control in the things that they would like to do, like communication between native code on the app and the WebView. And we've also improved performance by taking the WebView off the UI thread, so a long-running script in the WebView can't block the app's UI. These are just a few of the new APIs and events that we've added to the WebView. The one that stands out the most is the Add Web Allowed Object API. And what this does is allows smoother communication between the WebView and an app. So there's no passings of strings back and forth. You're actually able to directly call native Windows APIs, just like you are in hosted web apps from the web view. And then for Cordova, what we've done is, again, taken that same web platform and we've used to power the Cordova platform on Windows. What this gives us is support for packaged Cordova apps, where Cordova is in the package. You could put Cordova on the server for the hosted Cordova scenario, or embed multiple Cordova applications with the web view within one native app. And all the calling of native Windows APIs happens directly from JavaScript. So actually writing a Cordova plugin for Windows looks pretty trivial in some cases. It's just mapping of APIs. And for the summary, what I talked about today was web apps are just universal Windows apps. They're just like any other Windows application out there. They're native to the platform. They run across the Windows family of devices. They can be a hosted web app where it just points to your website URL. You're able to publish it to the store, and then any user on Windows is able to discover it and open it, install it on their device. Hosted web apps use code on the server to enable platform integration. What this means is JavaScript on your server is able to call directly into the native Windows APIs, just like the Cortana integration that I showed, the calling of other native APIs like contacts and appointments. You're able to directly do that from JavaScript on your server. Manifold.js is a simple way to build hosted web apps cross-platform. And Manifold leverages Cordova. It starts with a JSON manifest, and it gives you the opportunity to publish your web app across multiple platforms, not just Windows. And we'll keep intervening in that project in the future. Feel free to help us out. Security is controlled by content security policy. There's been a push to make that a standard, and we've adopted it as well. So content security policy just enables more frameworks to work on Windows. Frameworks that your applications use will just work now, and it'll be standard in Microsoft Edge and across the entire Edge platform on Windows, whether it be apps or browser. And then the Edge web view just gives more granular control to developers with a rich API set and interaction between applications.